Okay, well, everyone, thank you for joining today. I'm Kevin Cochran, and I'm with Vultr, and I'm excited to talk with you today about what we are seeing here at Vultr as enterprises embark on a new journey to roll out new changes to their data centers and their infrastructures to reinvent their application stack and build the next 10 years of AI native applications. Now, before I begin, it's important to note that I'm joined here by this cute little plushie, our Morty, our Himalayan vulture. And our Himalayan vulture has a very secret superpower. The Himalayan vulture is the key to an open, thriving ecosystem. And here at Vultr, we are committed to an open AI ecosystem. And it's for this reason that we are so heartened to partner with AMD to ensure that as we work together as a community, that we can work together to accelerate innovation at global scale. But before I begin, who wants an actual Morty here? We'll throw some out here to the crowd. These things are cute, and they're throwable, and they're the perfect throw for your dog when you play catch. So there we go, right over there. So this morning, we saw an unbelievable keynote. And we saw an unbelievable keynote because you actually saw the power of open collaboration and open innovation with all of the customers and partners on stage with Dr. Lisa Su. And here at Vultr, we have been a long-standing partner with AMD and our friends Supermicro. Our platform launched in 2014, building out data centers across 32 global data center regions. And we standardize on AMD data center CPUs to offer the highest performance and the greatest cost efficiency for some of the most demanding cloud compute workloads for our enterprise customers on the planet. Most recently, we were the launch partner for AMD for the EPYC 4005 series. And here today, we are so proud to announce that again, we are launching with AMD the new MI355X. Our partnership with AMD has all been about open collaboration. As we work with our partners, with AMD, with Supermicro, with Juniper, with Broadcom, building out latest generation data centers all around the world. When you have a partner like AMD that works hand in glove with you and your customers to listen, to learn, and to advance the roadmap. And it's for this reason that I'm so excited to be here today to share with you how we look to work with AMD and Supermicro to advance the next 10 years of cloud infrastructure. Now, we generally see in the compute world cycles of innovation. These cycles generally run on 10-year time horizons. And with each cycle, you have innovation across the entire stack. Application architecture, infrastructure architecture, networking architecture, storage architecture, and more. And again, what we saw on the keynote today is AMD reinventing the entire compute stack. The networking, the storage, the data center, the racks, all in an open, collaborative fashion to bring best-of-breed partners together to accelerate innovation versus building a closed, monolithic stack. Now, here at Vultr, we have seen successive waves of compute. Most recently, when we launched our platform in 2014, working with AMD, pioneering global cloud infrastructure to help enterprises as they move from web applications in 1.0 architecture to truly cloud-native web application architectures. And right now, where we are is we're at the dawn of a new 10-year cycle. Each 10-year cycle starts with some open research and some open innovation that quickly is followed by some proprietary commercialization that breaks in a new product market. That's what we saw in the early days of the AI revolution. What happens at this stage is an ecosystem forms. And the ecosystem brings together partners at various different parts of a stack. And once that ecosystem gels, what you see happen is enterprises adopt en masse an entirely new architecture for all of their workloads that they're deploying all around the planet. Right now, the roadmap we saw today is so perfectly timed for what we believe is mass enterprise adoption that will start at the end of this year and accelerate into 2026. So again, we're at the start of a 10-year cycle. And at this 10-year cycle, it's about an open ecosystem. And it's important to note that in this 10-year cycle, we're not just innovating in the GPU. The CPU does not go away. The CPU becomes more important than ever. And just as you'll see accelerated demand for GPUs, so too will you see accelerated demand for next generation CPUs. Here at Vultr, we deliver full stack AMD architecture, CPU, GPU, worldwide. That's what we're excited to talk about today. Because global AI adoption starts now. We recently, literally last week, completed a survey of over 2,000 senior level executives responsible for AI initiatives and AI budget planning. And the survey results were quite dramatic. It's actually the second year we've done this survey. The most important thing that we learned is that this year, over 70% of enterprise leaders were looking to begin the mass scale adoption of AI across every line of business. Last year, that was not the case. It was only 30%, because many of them were still concerned about issues related to infrastructure changes, data center availability, power, and most importantly, security and compliance, as well as upgrading their skill set. So this is a dramatic change within a very short period of time. Now, what that results in is the plans for these enterprise leaders, again, across all of North America, across all of Europe, was not just deploying one model, not just deploying two models, but actually harnessing the power of open source and open innovation and deploying hundreds of models across, again, every line of business function to support every operational process, both customer-facing and employee-facing. And as they're looking to deploy these models, these open source models, these lighter weight models, they want to stay on top of the latest innovation in the entire stack. What they don't want is they don't want to be locked into a closed walled garden, because they know what everyone knows is that innovation is only going to accelerate and you want to stay on the cutting edge. Open AI ecosystem was the #1 requirement for all of these enterprise IT leaders, the #1. When you see Lisa on stage, Dr. Lisa Su, I should be a little more respectful here, on stage, you see the warmth, you see the embrace, you see the working together with the community. This is what enterprise IT leaders want to see. They want to see people working in partnership with them and with their other partners so that they can be successful. What the other key requirement was, they were very concerned about making certain that the partners that were brought to bear could support them with the technical expertise and ensure that what they are doing is secure and compliant. Because as they're moving forward, they want to move forward fast and not break things. They want to move forward fast and actually make things and make them trusted and make them secure. Now, here at Vultr, over the past 10 years, we were a developer-led platform. No sales, no marketing. That's why probably none of you have ever heard about us, but we support over 250,000 customers all around the globe, 185 countries, data centers, like I said, strewn throughout 32 operating regions across all continents, reaching 90% of the world's population in between 2 and 40 milliseconds. And what we've learned over the past 10 years at Vultr is that enterprises, when they're building their stacks, want open composable application architectures and open composable infrastructure architectures that actually enable them to set up a hybrid multi-cloud deployment where they can orchestrate their workloads seamlessly across their on-prem environments and their off-prem environments in our cloud. Now, you also saw that in the keynote again today, which is the data and the data flows from your on-prem systems need to be able to be seamlessly shared with all of your GPU clusters that you're using for training and inference. Composable architectures at the application tier and at the infrastructure tier are critical, because if it's composable, that means that you can swap in and swap out different resource types so that as innovation occurs in the ecosystem, you can plug and play and test new services without any disruption. And if those new services help you operate faster and cheaper, then you can easily employ them and deploy them globally. What we're working on with Supermicro and AMD is a full stack AMD compute architecture where everything is plug and play, everything is composable. So you can pre-compose different stacks for different initiatives, leveraging different open source frameworks, different open source models, and you have complete fungibility to harness whatever is coming out in the ecosystem as possible. So let's take a little bit of a look at what this looks like. And here at Vultr, again, for 10 years working with some of the most demanding enterprises and enterprise compute workloads, we know that in this future of AI native applications, going from cloud native to AI native, that the principles of application architecture and application development do not go away. So what this means is IT ops processes matter, DevOps processes matter, SecOps processes matters. And we need to enable the enterprise to take all of the frameworks and processes that they apply for general development and apply them to this new AI world. Here at Vultr, we embrace the concept of platform engineering and enabling your platform engineering team to take advantage of new GPU architecture so your platform engineering team can be the centralized team that tests and builds new models and sets up the standards for how infrastructure is rolled out, that sets up the standard for what is a pre-approved, pre-composed stack, and actually acts as a choke point to ensure that there's governance, security, and compliance for whatever initiative is being rolled out by a downstream team in a region or in a business unit. So let's take a look at this platform engineering approach. What does this mean? This means that for the enterprise to truly be AI ready, they need to enable a self-service experience so that every development team can quickly and easily access the resources they need so they can just simply build and deploy. Build and deploy. Developers do not want to think about data centers. Developers do not want to think about setting up and configuring the GPU cluster. Developers don't want to have any of that brought to their attention. They want to innovate. They want to innovate at scale, right? So that needs to be completely abstracted for them. So the whole point here is that you need to have a centralized team that pre-builds those models, pre-tests those models, and says, here is the model garden, here is the services garden that you can pick and choose from in order to build and deploy your applications. And of course, all of these pre-built artifacts, all of these pre-composed infrastructure stacks need to be properly product managed. Every year, there's going to be new exciting GPUs coming out from AMD. Every year, there's going to be new exciting CPUs coming from AMD. Every 2 weeks, there's going to be updates to ROCm. So you need to have the internal team that actually can take these new innovations, vet them, test them, and upgrade the core artifacts, the core infrastructure templates that then can be safely and securely rolled out and deployed throughout all of your downstream team. Things need to be prepackaged with all of the built-in controls that ensure that you have the compliance and security you need when you're rebuilding your entire application stack. Because as we've seen in previous waves, every single application that you are running in your enterprise to support your employees, your partners, or your customer are going to be rebuilt. So getting this right is of critical importance. So what we're pioneering here with AMD and Supermicro is this concept of a composable cloud. A composable cloud that enables you as an enterprise to truly innovate at global scale to rebuild all of your enterprise applications, putting AI at the core. Not throwing away the CPU, as some people say, but coupling the CPU with the GPU so you can actually harness the combined power in every data center and every data center region for every single application experience. This composable cloud has both elements at the application tier as well as at the infrastructure tier. On the application tier, this is all your core microservices, all of the containerized application services that you're building to support your enterprise. It is now being extended for all of the containerized AI models. What are the models that are supported? What are the models that are properly tuned? What are the models that have been tested? And also, here at Vultr, it needs to also include the containerized data sets. We need to think about the data as an artifact. What was the data set that was used to train? What was the data set that was used to tune in a particular region? How was the data marshaled? From what sources? When? How was the data inspected so it was known to be good and compliant before it even went to test? We have to make sure that we're not just pre-building the services, not just pre-building the models, but pre-building and providing the security and the audit trails around the data sets themselves. At the infrastructure tier, we need to think about compute as a fungible resource. Today, in this day and age, it's amazing to me because everyone's scrambling to basically set up like one monolithic GPU cluster in Norway, and suddenly that's going to run the whole world. When does that make sense? It doesn't make sense. We know from prior generations of compute is distributed. You're going to have compute resources across as many regions as possible, all the way to the edge. So in the application world, we already know this. When we deploy an application, we're actually spinning up resources on demand in Tokyo. We're spinning up resources on demand in Johannesburg. We're caching at the edge in hundreds or thousands of POPs around the planet. That same model has to happen with GPU. So you need to be able to spin up and spin down GPU resources as easily as your CPU resources, and you need to spin up your GPU resources in the exact same regions you're spinning up your CPU resources. That means everywhere in the world. And it's not just for inference you need to do that, but it's also for training. You can't just have one monolithic training cluster. Why is that? Well, in different countries, there's going to be different data sets that you need to use to tune the model. And those data sets are going to need to be resident in that region. So when you're tuning your model, if you're in a heavily regulated industry like financial services or healthcare, the data that you're using to tune a model to predict patient outcomes in the United Kingdom is a data set that you can't pull into the United States in a centralized training cluster. So here at Vultr, we believe that infrastructure should be fungible resources, the networking, the storage, the compute, and it should be automated in terms of the provisioning everywhere in the globe, automatic, completely abstracted from the developer. This is what we call the composable cloud. It's a cloud that is a pre-built library of templates, infrastructure as code templates, built by your platform engineering team, product-managed artifacts that are open for community development. Why can't you have an entire community contributing to a marketplace of pre-built infrastructure templates? So if you wanted to move fast and get started with an example application, why can't you just simply take a pre-approved template and just quickly have that golden path to success, spinning up your combined AMD CPU and GPU clusters with all of your global security and compliance? Spinning this up is, what does that do? This is all about making certain that your GPU clusters on demand, based on your incoming workload requirement, be it training or be it inference, you could immediately scale up and scale down all of your MI355X clusters. Not today, 355X coming from Vultr, 325 is what's on docket right now today, but also spinning up your CPU clusters as well. And most importantly, making certain that you have the accelerated storage to support both. In what world do you just want a dedicated storage cluster for one GPU training cluster in Norway? That does not make sense. You need to have a unified storage architecture that spans the entire application experience. All of your application code running on your EPYC CPU processors, all of your containerized models that are running your Instinct GPUs. One storage architecture globally to support your entire application experience. And of course, the most critical part is the networking. And it is so amazing, Ultra Ethernet, to actually be able to have the high-speed, standards-based networking that supports not only the scaling your CPU and GPU clusters, but also the accelerated delivery of data sets to support real-time RAG and real-time inference as you're having direct connects between your Vultr data center and 900 different data centers around the world where you may be having colo for some of your other applications. So accelerated networking, the consortium built around Ultra Ethernet and the new standards, critical for unlocking the power of enterprise AI workloads. And these workloads aren't just a one and done. These workloads are dynamic. You'll have development teams all around the planet accessing these pre-approved templates and spinning up on-demand build environments, test environments, production environments for every single application, every single region, every single business unit. I think we saw in the keynote like how excited everyone was to see the AMD Developer Cloud. Isn't that awesome? You can just go and simply spin up a GPU. That's the whole point. Let's make it easy to actually spin up on demand any set of resources for any stage of the application development lifecycle. And it might just look like something like this. And when you look at the global architecture, making sure you have that integrated view of your traditional cloud native services, your CPU clusters, your CDN, your managed database, your integrated storage, your direct connects, your managed Kafka, all coupled to your GPUs, running your training workloads, your inference workloads, and actually exposing all of your serverless API endpoints so that you can actually run your models and couple that with your application experience. It's a unique combined architecture for AMD and Supermicro because we believe that it isn't 1 + 1 = 3, but together it's 1 + 1 = 5. Now, I have to admit, we do believe in open collaboration here at Vultr, and I have to do a shout out because I didn't make any of these slides. So these slides come from our amazing partner, Linda Yang, here in Supermicro. I literally stole her slides. So Linda, I'm sorry, but open collaboration in spirit. And of course, the editorial control over these slides was from our fine partner at AMD, Carol Whitmarsh. Because together what we're really doing is we're building that cutting edge integrated EPYC and Instinct architecture for first to market data center solutions that give you the best global reach and price to performance. It's all about the performance, the efficiency, the speed, the global coverage, and supporting that open ecosystem. And the advancements that we see with what AMD's doing with its entire software stack on top of its CPU and GPU is absolutely amazing. I personally subscribe to every single update to ROCm, and the blazing speed with which ROCm is advancing is amazing to watch. So this is, again, the power of an open ecosystem, moving fast, scaling smart, not only on the AMD software stack, but moving fast and scaling smart with Supermicro. Because as we're scaling and rebuilding our applications globally, it's critical that we do so with the greatest efficiency as possible. Efficiency not only in terms of our developer productivity, but efficiency in terms of how we are consuming resources, because we want to save the world with AI. We don't want to destroy our planet. And with Supermicro, up to 40% power savings, 40% water savings, 98% heat capture. And as Linda likes to point out, I'm nearly deaf, so this doesn't bother me, reduce the actual impact of people's ears in the data center itself by actually making it quiet. Again, my ear's already burnt, so that doesn't save me. So again, we're very excited here at Vultr because coupling the innovation from AMD, the efficiency of Supermicro, we add that to our global reach, making certain that developers everywhere, wherever they live and work, have access to first-class AMD Supermicro data center solutions and all of the ancillary services that we as Vultr can marshal with our ecosystem of over 200 application service providers to give you the greatest freedom, choice, and flexibility to enable your internal platform teams to test and innovate and pre-build all of the core artifacts and templates they need to empower all of the rest of your developers in the enterprise. And of course, being in this business for the past 10 years, we take great pride in the fact that we put security and compliance at the core of our mission. In this day and age of AI, at the keynote you saw in the opening video, it was all about trust, and trust matters. And you have to have a privacy first, a compliance first, a security first architecture so that the new applications you're building and deploying are safe and secure, i.e. they can be trusted. What we find weird is many companies renting a GPU that weren't companies 2 years ago. Is that safe? And here at Vultr, we put a primacy at making certain that in every region we operate, we're compliant with all local markets and regulation from data privacy, data residency, you name it. We want enterprises to be safe and secure as they embark on the next 10 years of rebuilding the enterprise. So last, we'll just talk a little bit about industry success. So here at Vultr, working with AMD and Supermicro, we're all about helping you achieve real business outcomes across core markets, financial services, healthcare, life sciences, manufacturing, and energy. We partner together with our customers. We work together with you to help you achieve your outcome. And that means understanding the core challenges you face for accelerating innovation and working together with you as a partner and with AMD and Supermicro as a partner, working together to cross those gaps in order to enable you to be success. And as I mentioned, you can look at an example solution just in the healthcare industry. And just in the interest of time, I won't walk through all of this. But the most important thing is as we work with you to help you map out a next generation application architecture, a next generation set of infrastructure templates you can roll out to your team, what's critical here is what we learned about at the keynote is the coupling of the CPU and GPU is critical. There's an application experience that you're delivering. In the healthcare case, the healthcare portal, the actual portal that the clinician or customer is accessing, both in a desktop web browser or on the mobile phone, it's an actual application experience. It's still running on a CPU. The CPU does not go away. The CPU becomes more powerful than ever because it's actually what's governing the GPU and what's actually driving the inference in the back-end GPU clusters for your models. This is how we look to accelerate industry outcomes, mapping out an entire template. And one of the greatest examples is our customer IPA Therapeutics using AMD and Supermicro for the discovery of de novo proteins. And one of the most amazing things working jointly with AMD and Supermicro is how we're able to give them that efficiency and that performance edge, literally double, triple the performance for their small language, medium language, and large language models with massive reduction in cost. Better performance, lower cost. Better performance, lower cost. That's the way forward. This is the 1 + 1 = 5 advantage, Vultr and Supermicro. And with that, I'd like to say thank you so much, and let's actually have an amazing 10 years as we rebuild the future together.